let's look at question 6 of a January 2018 paper. What it says here is the diagram below shows triangle PQR. It's PQR. Alright? Good. Here it says take the coordinates of R. Let me just copy this and paste it on another screen. The coordinates of R. So here, what you have is R being right here. All right, you have R right here. Now consider the x-axis. It's above 0. And consider the y-axis. It would be beside. You have some values missing here. So let's see if we can fill them in. 0, this would be 1, 2, so you have 3. So the coordinates would be, remember, x comes here and y comes here for the coordinates. X, it's above 0, so it's 0. Y, it's right at 3, so it's 3. So the coordinates would be 0, 3. Alright? Coordinates would be 0, 3. So you get 1 mark for that. Now let's see what else it says. On the diagram above, draw all of these drawings you're going to have to do. So let me copy these and place them in. See if I can remove this and put this down here. Good. I'm going to have to do some drawings now. Let me just erase what I have here. Here now, draw triangle P prime, Q prime, R prime. A reflection of PQR in the line y equal 1. Let's identify the line y equal 1 first of all. On the line equal 1, every point on it will have y being 1, even though the x values change. So what do you think that line is? Where is it that y is equal to 1? It's right here. So if y is 1 here, this line would go right across here. So that's the line y is equal to 1. And we want to reflect this triangle over this line. Alright? So it would be like putting a mirror right here and looking down in the mirror to see the reflection of this triangle. Now, each point will be equal distance on either side of the triangle. So what you would have reflected over, P would come here. R would be reflected. This is 1, 2 above, so you go 1, 2 below and come, no, it would be here. This is 1, 2. So you reflect 1, 2 over right over here. So remember this 1, 2. So it's 1, 2, and R, P, it's R would come right here, and Q, the distance 1, 2, 3, 4 to the line. So on the other side is 1, 2, 3, 4. All right, right there. So let's just remove what we did. See if we can remember the points, and then redraw that line or the triangle. P, 1 above the mirror line, it would be 1 below. So P prime would be here. Q prime, 1, 2, 3, 4 above the line. So we go 1, 2, 3, 4 below the line. So Q prime would be here. Alright. R is 1, 2 above the line, so it would be reflected 1, 2 below the line. So R prime would be here. So let's draw our triangle. It would be this connected to this, connected to this. Good. So that's our triangle. P prime, Q prime, R prime. Reflection in the line y equal 1. After that, they say triangle P double prime, Q double prime, R double prime. A reflection of triangle P prime, Q prime, R prime. Reflection of our new triangle in the line x equals 0. Alright, what is the line x equals 0? We're looking at it right here. It's the y-axis. Because at every point on the y-axis, x is 0. At this point here, when y is 1, x is 0. At this point here, when y is 2, x is 0. At this point here, so it's every point is either above 0, at 0, or below 0. So x is 0. It's the y-axis. We don't need to highlight any point again. So we can see the y-axis highlighted here. It is reflected. Now, R prime is directly on the mirror line. So R double prime would be where R prime is. So it's R double prime would be right there. Alright? So you would need to draw another point for R double prime. Now, P double prime would be reflection of P prime. P prime is 1, 2 on the left. No, P prime is 1, 2 on the right away from the mirror line. So the image would be 1, 2 on the left of the mirror line. So when you reflect what you have on the right, the same thing will come on the left. So it's P double prime right here. And Q double prime is 1, 2 on the right. So no, Q prime is 1, 2 on the right of the mirror line. So Q double prime would be 1, 2 on the left. So it would be right here. Q double prime. Let me use it. Let me use a different color to write these things. So what I would have, how did I erase this? Accidentally erase this. Alright, let me use different color. So R double prime would be right where R is. P double prime, what did I say? It would end up here. Right. P double prime and Q double prime would be, it was right here. So this new line, this new triangle, I mean, would be this, and this to here, and this to here. Okay, good. So it would look somewhat like that. All right. So that was our two new triangles. Now let's see what else the question says here to do. Describe fully the single transformation that maps the double primes onto the original triangle, basically putting it that way. Alright, this latest triangle back to the original, a single transformation that would map that. Alright, what you would have here, what could happen if you map this onto this? Alright, what you could do is consider what they say is a single transformation. Fully a single transformation, right? Suppose you have P double prime here, and you consider that this line would join them. Suppose you make a spin right here. For Q double prime, you join them with this and you make one big spin. And for P double prime, you join them right here around this point. Well, I say spin, but it's really rotate. Alright, now could it be possible for you to rotate it, and around what point? Let's see, considering this point. Okay, good. This and this. If you consider this as another point, join Q and Q, you could go this way and to the point, 2 to the right and 1 2 3 4 up. You could go 1 2 3 4 up and 2 to the right. So you could do this as well. If you consider the P and this P, alright, this P and this P, this R, I mean, R is here, and you could go 1 2 up, 1 2 up. You could do it by rotation, you know, a rotation of 180 degrees clockwise or anti-clockwise, doesn't matter, around the point 1 or 0 1. Could map the double prime onto the original triangle. Do you see that? You could very well do that. Alright, you could rotate the double prime, the new triangle, around this point and get it to match onto the original triangle. Because what I'm saying here is that if you consider going through this point and you make a spin, you make a rotation, you see P prime would match onto P, the original P. Let's try again. If you join Q double prime and Q through this point, then you could make a 180 degree rotation and they match. The other thing is with R, if you join R double prime with the original R, and you could just rotate right here 180 degrees about this point, and they match. So you could rotate triangle double prime, P double prime, Q double prime, R double prime around this point 0, 1, and you would get the original triangle PQR. So rotation 180 degrees about 0, 1. Whether clockwise or anti-clockwise doesn't matter, but you could state one of them. That's a single transformation that could make the mapping. Alright, so you had two transformations here. In the first place, there was a reflection over y equal 1, then a reflection over y over x equals 0. Alright, that went from the original to the latest triangle, but you could rotate the latest triangle around the point 0, 1 to make it map onto triangle PQR, the original triangle. Let's see what's happening here. Triangle PQR undergoes an enlargement of scale factor 2. Calculate the area of the image. Alright, an enlargement of scale factor 2, and you should calculate the area of the image. Enlargement of scale factor 2. Alright, now when you say an enlargement of scale factor 2, it means that each side would be doubled in size. Alright, now here this was 3, this was what? Well, let's say we don't have the direct length of this side, but we could calculate it using Pythagoras. Right, but if we consider this being a certain height, let's say a vertical height, and we turn this triangle making PQ the base, what will happen is this. Let me erase. I want a bigger eraser. Let me erase all of this and see what happens. Now let me turn triangle PQR so that PQ is the base. PQ is our base. Let me do it a different way. Let's use black to make it look like the original triangle. Alright, so now we have our P here, Q here, R here. P to Q was 3 originally, and the vertical height was 2. This height was 2. Alright, now at scale factor 2, what you could do is increase this to 6 and the vertical height to 4. So half by 6. Area is half base time height Be 6 4 is 24. Half of 24 is 12. Alright. 12. Does it give a unit? There are no units here, so let's call this 12 square units, right? 12, so it's 12 units square. Alright, that's one thing you could do. Now if you consider also, if you consider that this was a triangle and you have 3, the base is 3 and the vertical height is 2, and you say half base, half of 3 times height of 2, 3 2 6, half of 6, 3 2 6, half of 6 is 3. Alright, now remember, if you double the sides, that means if you multiply the size by 2, then you multiply the area by 2 squared, which is 4. So when you double the sides, the length of the original, of the final side, the doubled sides to the original would be 2 times, but the size of the area, the new area to the old area, would be 2 square, which is 4 times. So you could calculate this and then multiply 3 by 4 to get the 12 if you wanted. Calculate the area of this triangle without enlarging it, you get 3 square units, then multiply that 3 by 2 squared, which is 4, to get the 12 square units. Or as I did, I doubled the sides and then just calculate the area. Alright, but whichever way you want to do it, it's up to you. Alright, so when we look further at the question, I saw earlier that it gave a total mark of 10, which means that what we will encounter is a brand new question later on, question 7. So let's deal with question 7 at a later date.